For an example involving a couple of trigonometric functions, I'd like to sketch the region and find its area. This will be the region bounded by y equals 2 sine of x and y equals tangent of x on the interval x goes from negative pi over 3 to positive pi over 3. Now 2 times the sine of x will look like a sine function that has been given an amplitude of 2 in both directions. Pi over 3 occurs before we hit the maximum or minimum. The tangent tends to be a little bit calmer and then raises quite quickly once we start getting toward that maximum or minimum value. Now that means that there are actually two regions in question. Now when there are two regions in question, it means that your top function changes throughout the course of the interval. Now, due to the lovely symmetry associated with these two odd functions, what we could do is simply find one of these areas and then double it to indicate the other area. So what I'd like to do is work with this region right here. You'll notice that the top of the region, going from top to bottom, top of the region would be the sine function and the bottom of the region would be the tangent function. So top function is y equals 2 times the sine of x, bottom function is going to be y equals the tangent of x. Something I wanted to point out as well is that at that point of intersection, x equals pi over 3, or rather at that point that was given to us, the top function would be y equals 2 times the sine of pi over 3. Sine of pi over 3 is the square root of 3 over 2, so that would be y equals the square root of 3. The other function would be y equals the tangent of pi over 3, which is equal to the square root of 3, which verifies that this point of intersection that we have right here corresponds to the end of the interval. That way we don't need to worry about any additional area to the right. So with that in question, our total area is going to be equal to the definite integral from 0 to pi over 3, which we will then double to get the left side as well, of our top function minus our bottom function. Now, each of these can be integrated directly, which we will do. 2 times the sine of x will become negative 2 times the cosine of x. In a previous video, we were able to show that the antiderivative of the tangent of x is the natural log of the absolute value of the secant of x. Plugging in our bounds, we will get negative 2 times the cosine of pi over 3 minus the natural log of the secant of pi over 3. Minus, plugging in our lower bound, this will be negative 2 times the cosine of 0 minus the natural log of the absolute value of the secant of 0. Simplifying one layer at a time, this will be negative 2 times cosine of pi over 3 is 1/2. The secant of pi over 3 is the reciprocal of the cosine, so that'll be 2. Plugging in our lower bound of 0, we'll get negative 2 times the cosine of 0, which is 1, minus the natural log of the reciprocal of 1, which is 1. The natural log of 1 is 0. Outside of this, we will have 2 times. This will be negative 1 minus the natural log of 2 minus negative 2. Combining like terms will give us 2 times the quantity, 1 minus the natural log of 2, or 2 minus 2 natural log of 2. It's no longer necessary to write the absolute value because 2 is already a positive number.